So example number 2, a man owes 5,000 due in 3 years with an interest of 10% compounded quarterly and 10,000 due in 5 years with 12% compounded semi-annually. If the money is worth 8% compounded annually, what single payment at the end of 6 years will equitably replace these two debts? Okay, in this example is similar to the previous problem, plus the idea that the original debts for this case are present value, in which we're going to add interest with this particular time and interest rate. As compared to the previous problem, the original debts are considered future value. For this case, the debts are considered present value. And those two original obligations, again, to be settled with a single payment. So again, step 1 is let X be the size of the single payment. At the end of 6 years. Before we proceed to step 2 and step 3, which we draw a time diagram and identify the comparison date, first we're going to compute the future value of these two debts. So we're going to call F1, which is the future value of 5,000. So this is 5,000 times 1 plus the interest rate of this is 10% compounded quarterly, therefore its corresponding I is 10% divided by 4, which is equal to 2.5%. So our interest rate per compounding period is 0.025. Its corresponding exponent is, this is quarterly times, so this is m is equal to 4 times the number of years is 3, therefore this is raised to 12. This is equal to 6,724.44 pesos. And the second debt, its future value is, that's 10,000 times 1 plus, its interest rate is 12% compounded semi-annually, so I is equal to 12% divided by 2 equal to 6%. So the interest rate per compounding period is 0.06. And the number of periods, since m is equal to 2 and t is equal to 5 years, therefore n is equal to 10. This is 17,908.48. Now we can proceed to step 2 and 3. So the time diagram, this is due after 3 years, so we're going to place it on the third year, 6,724.44. This is due after the 5th year, so this is on the 5th year, 17,908.48. And this is to be settled on a single payment due at the end of 6 years. So we're going to place X on the 6th year. And now we're going to choose the comparison date. So the comparison date for this case is on the 6th year, which occurs on along with the payment. So this will be the comparison date. Therefore, this amount will accumulate towards the comparison date with n is equal to, since this is compounded annually, that's m is equal to 1. So, one compounding period per year. So, from the 3rd year to the 6th year, you have 3 periods. And then the second debt, 17,908.48, that is 1 year away from the comparison date. Therefore, its n is equal to 1. Since the arrows of these quantities are moving forward towards the comparison date, therefore, they will be accumulated with respect to the comparison date. And our next step, again using the equation, all payments equal to all debts Again, this is single payment, therefore our left side is X. And this is equal to the all debts and their accumulation. So for this quantity, 6,724.44 times 1 plus the interest rate is 8% compounded annually, so 0.08. And there are 3 periods for this quantity, raised to 3, plus second debt, 17,908.48 times 1 plus 0.08 raised to n is equal to 1 raised to 1. And this amount is equal to 27,812.01.